Hey everyone, welcome back. Today we're going to talk about the quadratic formula. The quadratic formula is just another way to find the solutions or x-intercepts for a quadratic. So if you have a quadratic that is ax squared plus bx plus c equals 0, so it's in standard form, and a, b, and c are constants, and a doesn't equal 0, then you can use the quadratic formula, this equation here, to find those x-intercept solutions. And it's just x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Let's look at how to use that quadratic formula. So example 1, solve by using the quadratic formula. If there are no real solutions, say so. So in order to use the quadratic formula, we need to know the values for a, b, and c. A here is 1, b is negative 6, and c is a negative 16. Now that we know our values for a, b, and c, we can plug them in to the quadratic formula. So negative b, or negative 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a times c, all over 2 times a. Now we just start simplifying. Negative 6 is a positive 6, plus or minus the square root of negative 6 squared, which is 36, minus 4 times 1 times negative 16, which is a positive 64, divided by 2. Now we combine the radicand. 36 plus 64 is 100. We can take the square root of 100, so that's 6 plus or minus 10 over 2. Now remember that plus or minus in the middle tells us that we have two possible answers. We have 6 plus 10 over 2, and we have 6 minus 10 over 2. Well, 6 plus 10 over 2 is 16 over 2, or 8. And 6 minus 10 over 2 is negative 4 over 2, or negative 2. So our solution then is that x equals 8, or negative 2. Those will be our x-intercepts. Let's do another example using the quadratic formula. Again, write your values for a, b, and c. A is negative 3, b here is 2, and c is negative 1. Then plug them into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And now we start simplifying. Negative 2 plus or minus the square root of 4 minus 12 over negative 6. This equals negative 2 plus or minus the square root of negative 8 over negative 6. Well, do you remember what happens when you take the square root of negative 8? Yeah, you get an imaginary number. So that means this quadratic has no real solutions. It's going to be a complex number solution. And this problem just wanted us to write no real solutions if there were no real solutions. Let's look at another example, just a little different wording. In this example, we're asked to use the quadratic formula to find any x-intercepts for the function. Remember, x-intercepts are the solutions to the quadratic. So when you solve that quadratic formula, you're getting the x-intercepts. You just need to provide them in intercept form, so as a point. So we just write our values of a, b, and c again. A here is -2, b is -1, and c is 3. And then we plug it into the quadratic formula. -b would be 1 plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And now we start simplifying. 1 plus or minus the -1 squared is 1. -4 times -2 is 8 times a 3 is a positive 24. That's our radicand. And then 2 times -2 for the denominator is a -4. And keep simplifying. 1 plus the square root of 25 for our numerator and -4 for the denominator. Well, 25 is the perfect square, so we can simplify that radical down to just a 5. And again, remember the plus or minus in the middle with our numerator tells us we have two possible solutions. So we have 1 plus 5 over -4, and we have 1 minus 5 over -4. So 1 plus 5 would be 6 over -4, or -3/2. But remember, we need an intercept, so that would be the point, -3/2, 0. And our second answer would be 1 minus 5, which is -4, divided by -4, or a positive 1, which is the x-intercept of the point 1, 0. So in this example, it was really about identifying x-intercepts. And x-intercepts just mean that we need to have point notation for our final answer. Now, let's talk about that radicand in the quadratic formula. So the radicand in the quadratic formula is b squared minus 4ac. This is also called the discriminant. And that discriminant tells us the number of solutions that we're going to have to our quadratic. So if you remember the previous lecture, we had these same three graphs. The first graph, it never intersected the x-axis, so we had no solution. Well, that is equivalent to a discriminant that is less than 0. It's a negative number. And remember the previous example where we had the square root of a negative number and we said there was no real solution? That's right. It's because we have complex solutions, two complex solutions. So that means they're going to be a plus bi, a real component and an imaginary component. Then the second example we had, our graph crossed at just one point. We just had one x-intercept. This is when you have a discriminant that's equal to 0. And then the last possibility, if you have a discriminant that's greater than 0, you're going to have two real number solutions, or these two x-intercepts. So let's look at an example of evaluating the discriminant and seeing how many real solutions we have. So here we're given x squared minus 4x plus 4 equals 0. Well, to find the discriminant, we still need to know the values for a, b, and c. A is 1, b is -4, and c is a positive 4. Then remember the discriminant is b squared minus 4ac. Now we just simplify to find out what the value of that discriminant is. -4 squared is 16 minus 4 times 1 times 4, which is another 16. And 16 minus 16 equals 0. And we know from above a discriminant of 0 means that we only have one real solution. Now let's look at a big doozy of an example. This example has 5 different parts, and it's really combining everything that we've learned about quadratics. So use the given function f of x equals 2x squared plus 2x minus 4 to complete the following. So let's just go piece by piece. Part A, does this graph open upward or downward? Well, remember, whether it opens upward or downward is based on the value of a. So a here is equal to 2. Since a is greater than 0, we know that this is going to open upward. Now, we should also write our values of b and c, because we're going to need those for the other parts. b is 2 and c is -4. Now, part B asks us to find the axis of symmetry and the vertex. Remember, you get the equation for the axis of symmetry once you find the vertex. So let's find that vertex first. Remember, the x value of your vertex is equal to -b over 2a. That's why we wrote out our a, b, and our c. -b would be -2. And 2 times a, which is 2. So we get -2 over 4, or -1/2. Now that's the x value of our vertex. So to find the y value, we need to substitute -1/2 in to our given function. So 2 times -1/2 squared plus 2 times -1/2 minus 4. And then we just start simplifying until we find that value of y. -1/2 squared is 1/4, and 2 times -1/2 is -1 minus 4. So we get 2 times 1/4, which is 1/2, minus 1 minus 4. 1/2 minus 1 minus 4 equals -4.5. So we know that our vertex is going to be the point -1/2, -4.5. So then we know our axis of symmetry is going to be the equation x equals -1/2. Now let's look at part C. Find the discriminant and determine the number of x-intercepts. Well, we know our discriminant is b squared minus 4ac, or here 2 squared minus 4 times 2 times -4. And that simplifies to 4 plus 32, or a discriminant of 36. And since the discriminant is greater than 0, we know that we have 2 real solutions. Okay, we're doing pretty good. Now let's look at part D. Find the x-intercepts and the y-intercepts. Well, we know that our x-intercepts we can find by solving the quadratic. -b plus or minus the square root of b squared minus 4ac over 2a. Well, that's -2 plus or minus. We already know the radicand because that's our discriminant, which is the square root of 36 over 2 times 2, which is 4. We can take the square root of 36, negative 2 plus or minus 6 over 4. And recall that that plus or minus tells us that we have 2 possible answers. And we know from part C we need to have 2 intercepts, 2 solutions. So one is 2 plus 6 over 4, and the other is minus 2 minus 6 over 4. So the first one is 4 over 4, or 1, and the second is negative 8 over 4, or negative 2. Now, solving for X or Y-intercepts. Remember, Y-intercepts happen when X equals 0. So if I scroll back to our original function, if we solve this function for f of 0, we get 2 times 0 squared plus 2 times 0 minus 4, or just minus 4 as our y-intercept. Okay, now for part E. Part E involves putting it all together. Sketch a graph of y equals f of x. So we're going to use all of the pieces we just found. In part B, we determined the vertex is negative 1/2, negative 4.5. So let's plot that point. Negative 1/2 and then down 4.5. There's our vertex. Now that we have our vertex, recall that our axis of symmetry is the vertical line that goes through that point. So I can draw my axis of symmetry. This is the line x equals negative 1/2. Now in part D, we found a few other points. The last point we found was negative 4, or 0, negative 4, our y-intercept. We can plot that. So here's our y-intercept, 0, negative 4. And we found the 2 x-intercepts, 1 and negative 2. Remember, those are points. So we have the point 1, 0 and the point negative 2, 0 for our x-intercepts, and our y was the point 0, negative 4. If you look at our graph, we now have 4 points that we can connect and get the graph for our quadratic. So I start at the vertex and I can graph the right-hand side, and then I can graph the left-hand side. And notice, just as we predicted in part A, this graph opens upward. It was a little bit of a doozy of a problem, a lot of parts, but taking it piece by piece, we got all of the little dots and pieces we needed to be able to graph that final quadratic. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.